This is eHobbyist blog, a log of electronics hobbyist activities aimed at city dwellers who have limited space, limited money, and limited time. My name is Neil. Welcome. During this video, we will finish constructing the Plan B variable positive power supply. I won't be testing it though. I lied. Now what I've done here is fully populate the strip board with all of the inactive components and diodes. I'm going to try this new approach, just load everything first, then solder it, and then clip it, and see how much we can improve productivity. I gotta make sure the components don't fall out. It's kind of hard to determine which leads are associated with which component. I'm using an 1/8 of an inch chisel. This time it's at 300 degrees. I usually solder at higher temperatures. Clip off the leads. I was going to solder first and then clip, but the leads get in the way too much. I heat up one side of the lead, apply the solder to the other side, and notice I'm moving the lead while it's cooling, which is not a good thing. Alright, so it goes. Somebody forgot, once again, to turn on the exhaust fan. I don't like to clip these leads too closely because I've been known to take projects apart and reuse components. This strip board is on a 1/10 of an inch grid, and I decided it really does need some additional flux, make the solder flow better, even though the strip board is tinned. I thought this was a fiberglass epoxy board. I'm not sure now. The color is kind of right, but it was just too easy to saw. Uh-oh, what happened there? That's difficult to tell. I might have a bridge there. You just keep on going. Problem is my sloppy soldering technique. I put too much solder on, and that is the cause of all of my troubles. Okay, come on. That is a bridge right there. Okay, it's kind of on in the center of the board. Eek! Well, it's sloppy soldering, but it's not the end of the world. I'll fix it later. Just let me see how many bridges I can get on here. I should have used a thinner chisel. This is 1/8. I should have used a 1/16 inch. Now let's see what's actually going on here. There's I think a big solder bridge to cool it down with canned air. Yeah, that's definitely a bridge. All right, now this is solder wick. It's old stuff. I didn't know whether it had flux on it or not, so I put some more flux on it, which can't hurt. and the braid just sucks up solder. So, okay, there was a bridge. It's not a catastrophe. I can fix it. Could also have used a desoldering tool, but the temperature on that's about 340, and I figured it's a little too high for this. I might separate the trace from the substrate. I'm using a scribing tool to ensure that the traces are not connected. Sometimes it's difficult to tell visually. So it looks like this bridge has been repaired. Go on to the next bridge. Now we're adding the wire leads to this. That's the ground strip. There are actually two of them on either end, connected by that jumper. And the sensing wire that goes to a 2.5 megohm pot. That yellow line is the output power. I'm trying to maintain the same color code as the binding posts. And now we have the black and then the red power input. And get that out of the way. And do I have another bridge there? It looks like it. Ah, foo. Come on, man. One of these days I'm going to learn how to solder. All right. The solder bridge is not a big deal. Just don't panic. Keep on keeping on, and it's highly fixable. In most cases, as long as you don't apply too much heat, because it is possible to lift the trace from the substrate. This brown wire is the output ground going to the brown binding post. Note to self, next time use a smaller 1/16 inch chisel tip. Now what I'm doing here is applying epoxy glue to the wires where they meet the board. This is strain relief, additional strain relief. You can get some degree of strain relief by just pressing the wire into the board as you solder, but that could affect the solder joint. This is that 5-minute epoxy that sets in 24 hours. This is sometime later. I'm holding the wires with a hemostat while twisting them. These wires are the set that goes to the voltage adjustment, the voltage control. Slipping a heat shrink tubing over it. And these two wires are the outputs. Clip it to a hemostat so you don't break the wires off the board that I just soldered, and twist them. And twisting is basically a matter of dressing the wires. It also ensures that if there is some electromagnetic interference, it's on both ends, both positive and negative, and should cancel out to some degree. It also adds a certain amount of inductance. And these black and red wires are power input. This would come from the rectifier filter boards. I'm now using a surface mount rework station to apply hot air and shrink the heat shrink. Now this is the 2.5 megohm pot. And just soldering this in. Apply some flux here. Now solder the adjustment wires to the voltage adjustment potentiometer. These wires are getting in my way here. I need a third hand. No, not the gizmo. I need an actual third hand. Apply some canned air. And now let's solder in the LT3080. I'll make sure it's relatively stable. The 3080 should protrude a little bit beyond the edge because it's going to have to be bolted to the enclosure panel, which will be used as a heatsink. Now I'm using a smaller tip on the soldering iron, also at 300 degrees. It's a Hakko soldering iron, which is relatively cheap, but it works quite well, much better than I thought it would. I didn't think it had enough thermal mass to really deal with these low temperatures, the 300 degree situations, but it apparently does and works well, and is relatively quick to bring the tip up to temperature. And now that I have the right size tip, I'm not getting any solder bridges. The tip is a little thinner than the traces. In this video, I soldered inactive components to the board and cut off excess component leads. I removed unintended solder bridges using solder wick. I soldered wire leads to the board and epoxy glued the wires to the board. I twisted related wires together and applied heat shrink tubing to them. I soldered the LT3080 IC to the board. In the next video, we will be testing this board. If the board appears to work, it will be used as the prototyping system's single-ended 20 to 0 volt positive variable power supply. We will then construct a second board to function as one half of the 20 to 0 to minus 20 volt complementary variable tracking power supply. If the board does not work, we will resist the temptation to see how far a Wriggle oscilloscope can be kicked, and will troubleshoot the board. If you like this video and the idea of the channel, click on the YouTube thumbs up icon. If you want to be notified as to when the next video is available, click on the YouTube subscribe button. If you want to suggest future directions or topics, make corrections to published videos, or voice your opinion on related matters, then leave a YouTube comment. If you want to see supplementary material that cannot be easily presented in video form, such as high-res graphics, files in different formats, lists of references, go to the corresponding website. Until the next time, good day.